Alright, we're back here on the lathe. I just turned up this screwdriver. It's a parallel bit screwdriver, 1/2 inch long and 80 thousandths thick. This is just some 12L that I had laying around. And that's a good fit in the screws. Let me grab a crescent wrench here. Like, I didn't turn these flats in the back to anything specific. I always planned on a crescent wrench being the tool, or an adjustable wrench for some of you. So we're going to get this in here. And I'm going to push with my, yeah, that's a pretty bad view. Let's see if we can get you guys a little better look here. Let me, all right. So I'm going to push in on it while I am attempting to rotate it. And we snapped off my tool. So that was awesome. That means I need to go build a hardened tool. I didn't harden this at all. I just figured, what the hey. Let me see if we still fit. Let me just go clean that up. Maybe when we get down here, we get enough meat here to survive. So let me go clean this up on the sander, and then I'll be right back. Alright, we're back for take two. So again, I'm going to get my crescent wrench on here, and this thing's been blunted down pretty good. So there's very, very little parallel surface, so I'm hoping this will survive. So again, I'm going to press in and sheared it off. So clearly those are in there pretty good. Well, I guess we need to make another one of these. I'll bring you guys along. Alright, so here we got a piece of 4140 chucked up in the mill. I'm going to go ahead and touch off, get some zeros on my Y. It's probably good on the X. I'll go ahead and zero the X out right there, actually, just so I can work towards that. So I do have the tools to touch off and get an accurate measurement, but I know what this is. This should be some 7/8 material. And we're going to use a half function. Puts our center at, so here's our 0 right there, and then I'm just going to eyeball that and confirm. Yep, looks like a 0. Looks like we're in the center vertically. So now I want to move back 3/125, which is 5/16, because this is a 5/8 inch end mill. So 3/125, that would put our edge at 0. So now we're going to move another 40 thousandths because we want an 80 thousandths thick blade. So we're going to go to 3/525. Past it. Coming back, get the backlash out. 3/5. I'm going to take 3/5/248. And then we are going to just walk this in until we get it to our 0. Alright, that was our first pass, and then the far side, so we're going to come to the near side. Again to 3/5/25. in the other direction. Remember, my 0 is in the center of the bar, so I'm going 35, 25 either side of it. All right, so that's our blade. I'm going to turn this 90 degrees because we want to make this 1/2 inch. It does look like I needed to come down a little bit more there, and that might have been why we're getting a little bit of sparkies. All right, so again, accuracy is not necessarily the most important thing here. But good calibrated eyeball. All right, so now we want to make the center, instead of 80 thousandths, we want to make it 1/2 inch. So 3125 plus 0.250. And I'm not going to pretend, I'm going to use a calculator. Of course, that means you can find your calculator. Pencil and paper it is. Man, you think this shop is worked in? I can't find shit today. So just right here on the top, let's see. 3125 plus 250, 5265, 5625. So I'm going to back our Y off to 5625. 56248. I will take it. Again, this is 4140, so this is a hardenable alloy, and we will harden it because clearly a non-hardened does not work. And I'll just take a couple measurements here, just with the guessometers. .490. So again, I wasn't aiming for perfection there. Mostly because all this is just the width to get into the slot. I'm going to need a little bit of room here. $25, $50, $75 plus 4, $79. So that is 79 thousandths thick. Again, 80 thousandths was our target, so we got both of our major dimensions close enough. I've got this 4140. I cut off about 6 inches of it. I don't actually need 6 inches of it, but my theory behind this is 6 inches of 4140. If I decide I don't need this tool anymore, will make a good next tool. But it also helps if I need to get into some tough places, even though our current condition is that we don't. So first thing I do is I'm going to face off the end, and then we're going to put some flats in at about 650 from the center on both sides. I'm just taking 100 thousandths off. That way we can get a nice purchase with our crescent wrench. So let's just bring this in. I think of Chris, why are you using the auto feed? And that's because the handle is actually across the other side of this camera. It's over here, and I don't want to reach across the camera to operate the handle, so this will do just fine. So I'm going to lock the Y, lock up my X, and take a pass here. 5/8 cutter at 825 RPM. So now we're going to come in. Well, I'm awful close already where I want to be. To should be 650, which is right there. And that'll give us a nice cut on the flat. Let's send it. Looks good on the back side, so we'll lock our Y and we'll go to 650 on this side of center. And there we are. Lock the Y up again and we'll send it. There we go. Now both of these flats are cut, so I'm just going to loosen this up. And I could dial this in, but like I said, this is just flats, so really we just really have to be 90 degrees to the opposing face, not necessarily 90 degrees to their adjacent faces. So I'm not super concerned about indexing this thing 90 degrees, 180, so on and so forth. Just as long as I cut them both in the same setup, both sides of it, front and back, the crescent wrench will have a good purchase. Alright, let's send it. And there we go. That is our finished tool. So, here's what we've made. We put a pretty respectable square so that we can get a purchase on that with a crescent wrench. One of the nice things about doing this in a mill is that it leaves you with these radiused edges on both ends. So when we harden this, those radius edges will help prevent cracking because we haven't given any place for a stress riser to form. So I'll go back and before I harden this, I'm going to just relieve the edges here on the belt sander. Make sure I got this all cleaned up here, which I think I do. I tested this when I went out to cut it off to the 6 inches, just tested it on the screws, made sure it fit really well, which it does. So we're going to do a quick thermal cycle and hardening on this and then temper it. So this won't be ready for use today, but we'll have it ready for tomorrow. Mostly because I got to harden it, and then on tools like this I'm going to do 2-hour cycles at about 450 to put some toughness into it. So we don't want it to be brittle. We want it to give, but not give a lot. So that's the heat treating process I'll use for this. I'll do this probably in the propane forge. Just get her up to temperature and harden it, and then when my wife goes to bed, I'll use the kitchen oven. She'd probably never notice, but anyway, those of you that know her probably know what I mean. So we'll temper this this evening when I go back into the house, and we'll have a usable parallel flat bladed screwdriver, which is basically what this is. Made out of super tough material, and they'll help us get those screws out of that out of the gearbox. Alright, so we're back. We've got the tool ready to go in the forge. It's getting heated up. I'm going to put it in with its square end first. Just want to get the heat to the end of the tool for hardening. I'd rather have the heat sink in the back behind it. So let's go ahead and do that. Now we wait. flux on the working end, just to protect that from scale since we like the dimension. And I'm going to let this go ahead and cool down. Alright, so now I've placed the part back in after a cooling cycle. It was, I don't really take a temperature, but the back of my hand could touch it and not get burned, so whatever that temperature that is. So it's still got the flux there on the working end, and we're going to bring this up to temperature slowly, probably over the course of maybe 20 minutes here, and then probably hold it for a couple minutes, and then we'll go into the quench. Well, we're getting close to temperature here, so it's been holding there for about a minute with that color. So I'm going to set up on the quench tank, and we will harden this piece. Alright, I just checked it. It is non-magnetic, so we're going to go ahead and quench it off. And I'm just swirling it around. And this takes longer than you think. You know, a piece this size, probably 15 seconds, 20 seconds. I guess when I pull it out, we'll know. There we go. And no flame ups because we let that cool down. So I'm going to go ahead and wipe this down and scratch it up and cool it off. Alright, here we are out of the quench. You know, it's still toasty warm. Chainsaw file here. That's right on the side of the bit, so yeah, we're hard. Yep. So be careful with this for a little bit. Now with 4140, it is best to get it into the temper as quick as possible. So I'm gonna clean this up, take it in, and put it in the oven, and we'll be back after we're hardened and tempered. I have hardened and tempered our screwdriver, and as soon as I put my fingers on the crescent wrench, wherever it went, we're going to try this again. Just sizing the crescent wrench here. Alright. So pushing in. Oh, and it turned. There we go. There. Press in. Oh, it moved. There we go. There we go. Simple tool. Doesn't have to be pretty. But it is working. Here we go. That's how the tool works. And that's a shorter one. Alright, so we got it broken loose. Believe it or not, the paint up here is holding it right now. best I can tell, that should be all of the fasteners. This is already well separated over here, so. Alright. Just leave you guys there while I work on this side. Alright, I think that's ready to come off. So. There we go. Gearbox is loose. So let's see if I can lower it to the ground without dropping it. Wasn't very graceful. Alright, so we've got our gearbox off of the lathe. Pretty exciting to be able to expose that. Next up, take it to the workbench and we'll work on disassembly.